All right, so here we're specifically looking at number 13 from 5.4. This is a regression problem. Again, this is not really covered in the course. This is a really nice skill to have, but I don't want you to think this is going to show up on an exam anywhere. So the idea is that you've got two variables and you're going to use your calculator to create a regression, meaning like a line of best fit between them or a curve of best fit. So linear regression, typically what it does is tries to minimize the distance between the points and some trend line. So if you've, this is not this data set, but if I'm making up some random data points out here, it's going to say, well, if we calculate the distance between all these points, it might draw some line and say this represents the trend. We call this like the regression. And this will have some equation, y equals a plus bx, and then from there you'll be able to use that to make predictive values, right? To kind of carry the pattern forward and make predictions about what might happen in the slight future or what would have happened just in the past, etc. But so here we've got two variables that are growing. The y is growing really, really quickly. And so in the back of our minds, we might think that a log model is a better fit for this to kind of flatten out those huge differences. But in any case, this is the point of the problem, is to try to highlight this. So it's saying, all right, make a linear regression. And the only way we do this, we don't do this by hand anymore. You do this using the calculator. And so you would need to be familiar with the TI. I believe there's a way to do this in Desmos, but I'm not quite sure how to do regression there as of right now. But if you use the stat feature, edit the lists, just look at list 1 and list 2 for right now. This is the table that you see from the problem. Okay, so you have to enter these into these cells. And then, so you want to pause while you do that, right? I'm going to continue though. So you enter those in, and then you'll come to the stat button again, and you'll come over to calculate, and then come down to linear regression, this first one here. And what this will do is try to create a linear equation that fits best between these sets of points, where x list is L1, y list is L2. That all looks good. Hit enter, and that will give you this equation. And again, b is like your y-intercept, and a is your slope. R is the correlation coefficient. What that means is how good of a fit is this to being a line. And this is a measurement that you go into in statistics. Here we don't really talk about it too much, but the closer to 1 it is, the better it is. So 79, it's good-ish, but it's not the strongest fit. So that's part 1, is to just generate this equation, and you just do this through the technology. We don't do this by hand. There's no I haven't taught you how to do this by hand, nor would I ever, because it's a pain. But the other piece is to say, now that you've done this, maybe create a third column, which we'll call the natural log of y, and generate this list of values, and then do a correlation instead of between L1 and L2, between L1 and L3. Let's see if there's a better fit between x and the log of y, right, when we shrink down those big jumps. So there's a few ways to do this. One way would be to just physically calculate the natural log of each of these values, and then just shoot them into this table, make a new table with just the log of these values. The other way, if you want to be really slick, would be to go to the second list feature and say, well, first of all, we want to take the natural log. I want to take the natural log of list 2 and put that into list 3, so I don't have to do all that manual labor. If there were 40 entries, this would probably be what I recommend you do. So you come to, we take the natural log, now we go second list, and put in L2, because we want to take the log of everything inside this column, and then we store, which will shoot that into second list L3. So that will just tell you, all right, I shot all these values over here, and now when we look at our list, you'll see that this is the case. And if you did it by hand, these should agree with what you did. So now that we have that, now I can do a regression between L1 and L3, where this is my x and this is my ln of y. And so we'll do that, stat calculate linear regression. But we're going to have to come up here and change this guy to be second list L3. And then calculate. And then here we'll see, okay, this generates a different line now that we've taken the log of all those y values and flattened them down. The a and b are obviously different. This is a very, very different line. But what do we see about the r value? The r value is 0.999, which means this is a very strong fit. Okay, so this log regression here does a great job, meaning this is an exponential function, or very, very close to it. Okay, so that is really the whole goal here, is to highlight those two things. But I think the key breakdown and the confusion here was on using the calculator. So there are a lot of videos out there on how to do this if I did that too fast, but that's how you use regression.